Hello everyone. Today we are doing the equation of motion by the graphical method. You can see that the initial velocity it is given as u, the final velocity it is given as v. So this one it is given as u, the final velocity it is given as v. From here to here it is given as t. Okay, any of our object it has started from u, it is moved to it is moved with a uniform acceleration, and it reached to a final velocity v, and it has taken a time period t. So we will do the motion of equation of motion with the help of the graphical method. Now the first equation which we have to do, it is known as v, it is equal to u plus at. So we have to derive this one, v it is equal to u plus at. So how to derive this one? It is given as u, this velocity, this whole velocity it is given as v. So what do you have to do? You have to find out the value of the slope in this one, and the slope, it means that you have to find out the value from here to here, this distance from here to here and from here to here. So you know that from here to here the total value it is given as v, and from this v you have covered a distance of u. So the total which is left behind, that one is given as v minus u. Okay, so the acceleration it is equal to change in velocity. So acceleration it is equal to change in velocity upon time taken. We know that as the acceleration it is equal to change in velocity upon time taken. So we will write down this one as acceleration it is equal to change in velocity upon time taken. Now the acceleration it is given as the change in velocity upon time taken. So acceleration it is equal to change in velocity. So what is the change in velocity? It is v and it is u. So change in velocity is v minus u, upon time taken is t. So from here v minus u it is equal to a into t. So from here you will get a formula, v it is equal to u plus a t. That's it. This one is the first equation of motion. So dear student, in this one we know that the initial velocity it is given as u, this one the final velocity from a to b it is given as v. So this total distance bc, it is the combination of bd plus dc. So the value of v, this total v, it is equal to bd plus ao. So the value of v it is equal to bd plus AO. So you can see that the AO it is equal to U. So this distance is equal to U. So from here you can write down this one as it is V, it is equal to BD plus U. What is this BD? BD is acceleration. So acceleration is equal to V minus U. Okay. Now from this BD, so acceleration it is equal to this BD. So you can write down this one as acceleration it is equal to change in velocity upon time taken. So change in velocity, this change in velocity is v minus u upon t. So from here v it is equal to u plus a t. Okay, this one is the first equation of motion. Now moving to the second equation of motion which you have to do. The second equation of motion, it says that s is equal to ut plus half at square, this one. So it is the combination of two triangles, two areas. This one is the first triangle and this one is the rectangle. So it's a combination of this one, that one is 1 and this one is 2. It's a combination of these two. So you have to find out the total value of area covered in this one, or the distance covered in this one. So the distance traveled by the body in a given time period by the area of the space between the velocity time graph AB and the time axis OC, which is equal to area of the figure OABC. So the distance traveled it is equal to area of triangle plus area of the rectangle. Firstly we will talk about this rectangle. When we talk about this rectangle, you know in rectangle we have u and this one is given as t. So in case of the area of this rectangle, so area of 2 it is equal to length into breadth. So the value of the length it is given as t and the value of the breadth it is given as u. So the area of the area of the second this rectangle, area of rectangle, it is given as u into t. So from here dear student you get the area of this one as u into t. So you can write down this one as u into t. So this one is the area of this rectangle. So the area of rectangle you got from here, it is equal to u into t. Now the second one, you have to find out the value of the area of this triangle. Now area of triangle, it is equal to half into base. Now in case of the base means the distance from here to here. Okay, so the base, it is the distance from here to here, it is given as t into this height BD, and we know that the value of BD, it is equal to, from here to here it is V, and among from this V you have deducted the value of U, so this BD, it will be V minus U. So from here, now we know that if clearly we see the diagram, in this diagram, you know that this one, it is given as the area of this one is U into T. This one is the area which we got from here. This one is U into T, OA into OC. Now again, from the first equation of motion, we know that the first equation, it is given as V, it is equal to U plus AT. So from here, V minus U, it is equal to A into T. So what is the value of V minus U? The value of V minus U is A into T. So what do you have to do? Just write down AT in this one in place of V minus U. When you will write down AT in this one in place of this V minus U, so the formula which you will get, this one is half AT square. So what is the area of the first one? UT. Area of the second one, half AT square. So the total area which you will get from here, it is the combination of area of first, that one is UT, and the area of the second, that one is half AT square. Okay, so this one is the derivation for the second equation of motion. So you can say that the distance traveled, it is equal to area of OABC, area of rectangle plus area of triangle ABD. So this one will be equal to S is equal to UT plus half AT square. Okay, so this one is the derivation for the second one. S is equal to UT plus half AT square. Now we are moving to the next one, and this one is the last one, where you have to find out the area of the trapezium. In this one you have to find out the area of the trapezium, and this one is one of a very simplest one. Area of a trapezium, it says that you have to take this whole area. This, when you take this whole area, so it will be, it is equal to area of trapezium. It says that it is the sum of parallel side into half into sum of parallel side into height. So you will write down this one as half into sum of parallel side. Sum of parallel side means this distance and this distance, and you know that here it is given as U, and this total it is given as V. So you will write down this one as U plus V. Half into sum of parallel side into height, and the value of height, it is given as T. Height means this distance from here to here. This distance, it is said to be height. So this distance, it is given as T. So you will write down this one as half into U plus V into T. So dear student, from here you get the equation as, when you will write down the equation, it will be in this form, as it is equal to U plus V, sum of parallel side, and into half into sum of parallel side into height, and the value of the height, it is given as T. Now from the first equation of motion, it is V, it is equal to U plus AT. So the value of T, it is equal to V minus U upon A. Value of T, it is equal to V minus U upon A. So you will write down over here S, it is equal to half U plus V. In place of this T, you will write down this one as V minus U upon A. Okay, now this S, A and 2, this term S, A and 2, this will be 2AS. It is equal to A plus B and A minus B, it is equal to A square minus V square. So it is equal to V square minus U square. So this one is the required answer. That one is V square minus U square, it is equal to 2AS. Now you can also see in this one the derivation which is done over here. It is the sum of the trapezium. S is equal to sum of the parallel side into height upon 2. So S is equal to U plus V into T by 2. V is equal to U plus AT. AT is equal to V minus U. T is equal to V minus U upon A. On putting the value, you got the answer V square minus U square, it is equal to 2AS. Thank you, students.